my people, it's Newbie back again with a lot of frustration. And I'm not in the normal environment. Hey, so a bag of dog food behind me. That's a really good backdrop, isn't it? Show you a bag of dog food. But anyway, why I'm here is thanks for watching, thanks for subscribing and all that stuff. But today we're going to delve kind of into the weeds of what this is all about. Now, those of you that have been watching, you know I've been working to get the turnouts to be computer controlled. This is a Kato turnout, and this is I think this is an Atlas. Is it? I can't see it. Anyway, whatever. This is a snap switch, and this is a Kato turnout. So these are basically the two turnouts that I have on my layout. This one is 3-wire, and wait. This one is a 3-wire switch, and it has 3 wires. There's a black wire, which is a common wire, and then there's a red and a green. And the way these turnouts, the way these snap switches work, is that the direction of the switch is determined by which two of these wires, the common to the red flips it one way, common to the green flips it the other way. So trip and close, or close and throw, whatever. Okay, and then this is the Kato switches are 2-wire, and the way they work, and I haven't even gotten this one apart yet, but anyway, the way they work is that they're only 2-wire, and when you put, and it does, you flip the polarity. So if positive is on the red wire, it will trip. If negative is on the red wire, it will close, or vice versa, one way or the other. So that's the difference in the two systems that I'm working with. No big deal, because what I have is I have these. These are, I'll hit this up. Maybe it'll focus on it, maybe it won't. Anyway, what these are, this is what's called a MOSFET. And basically what it is it's an electronic relay. And the way it works is the orange wire and the green wire are the trip. So the green wire in this particular case is a ground, and so the orange wire is the signal wire. And so what happens is that you put a voltage, and it can be any voltage, into this side of the MOSFET. So these 2 wires coming into here, the bottom one is a positive and the top one is a negative. So in this case, the orange wire is the hot and the black wire is common. And so you put any voltage. So for example, you could put 120 volts on this. And then what it would do is when you send a signal on the orange wire, it will turn the MOSFET on and throw this voltage right through, and it'll come out on these 2 terminals. So basically what it amounts to is, the way I'm using these is I'm going to use these to control my turnouts. And so I'll have 2 of them, for example, for any given, for the Kato turnouts, for example, I'll have 2 of them. One of them will have positive on the bottom terminal and negative on the top, and the other one will be vice versa, so it'll be reversed. So there'll be two of these. They'll be wired differently so that they'll send a different polarity to the trip and close on the turnouts. I don't know if I'm being clear with that or not, but anyway, so what will happen is I'm using an Arduino, and I'll show you that in just a second. I'm using an Arduino to send a signal to the orange wire that will tell the turnout to trip or to close, depending on which one it goes to, okay? Neither here nor there. Actually it is, but so that's what I'm trying to do. It's what I'm trying to accomplish. And I'm doing that through JMRI, CMRI, and I've been working on this for months, and I'm really getting frustrated with it. And so, but let me show you what I've got here. Let me turn the camera around, and we're gonna look at this. Okay, first thing we're going to do, we're going to talk a little bit about software and programming, and in particular the Arduino, which is programmed in C++. But it's a trick. It's done with wires. Anyway, this is the Arduino software program, the way it comes up on my laptop here, and hopefully, let me see if I bring that a little closer, if it'll stay in focus. Hopefully you can see what's going on here. This is just a simple program, and in simple programming, what we're doing here is we're identifying a pin on the Arduino. Hold on. This is an Arduino, which is basically, it's just a mini computer, and I've got a couple of them here. So, but what we're doing here is we're saying, okay, we're going to identify a pin on this Arduino. I don't know if the camera will focus on it, but along here there's pin numbers on all these little holes. Those are what's called the pins, and they're all numbered. And so here I'm running a little simple program, and the first thing you have to do is you have to tell the software what you're doing, and they call it in the program language, it's called void setup. So basically what I'm saying is, okay, here's what I'm going to do, computer. I want to set up a program to run. And so you do void setup, and then it says pin mode 7 output. So what I'm saying is that on the Arduino, we're going to call pin number 7 an output. That's what the setup is all about in this simple program. And then we do a void loop, and the void loop is actually the program you're telling it to run. And here we're saying digital write 7, so we're saying write pin 7 high, and then delay 500, that's 500 milliseconds, and then we do digital write pin 7 low, delay 1,000 milliseconds, or 1 second. So basically, once you download this program into the Arduino, it will constantly run that program, because I didn't say stop or anything like that, so it'll just constantly run that, which means it should put pin 7 high for 500 milliseconds and then pin 7 low for 1 second. Okay, now, having said that and having done that, here's what it looks like. So you see here, I have the Arduino, and the Arduino, this is pin 7, this is ground over here, and let me make sure I got my hands out of the way so you can see, but this is pin 7 and this is ground. And this red wire, which actually changes colors, but it becomes the orange wire going into the MOSFET. And so that is the signal. So pin 7 is going high for 500 milliseconds, and then pin 7 is going low for a second. Now, the other thing I've got here is I can hold on, here we go. Okay, there you go. So on this breadboard here, I've got these two tracks on this breadboard run in this direction. They're all tied together. So this red line and this blue line are tied together. All these holes are the same on the red and the blue. And the red positive here, I have a 12 volt source, and negative is ground. So this red wire and this black wire come over to this side of the MOSFET. So it's basically putting 12 volts, positive and negative, on this side of the MOSFET. What the MOSFET is doing is turning that on and off. So when it turns it on, it feeds that 12 volts straight through to this side and puts the 12 volts on the LED. So if this was the turnout and I was doing this, what it would be doing is it would be sending that and telling the turnout to trip or close, depending on which way it was going, of course. So that's a simple setup. That's simply the way it's supposed to work. Okay, so now I'm letting that run, but now I want to show you the code that I've written for running the turnouts. And I've still got some work to do on this, but the bottom line is that here, let's see if I can zoom in a little bit, see if it'll catch that. Oh, by the way, let me back up just a second here. Explain one other thing to you about this. This button right here in the software, this is the compile button. So once you write a program, if, for example, you see at the end of this line, there's a semicolon. If I typed a colon instead of a semicolon, it would not accept it. That would be an error in the code. And these brackets and the parentheses and all these things are part of programming, and you have to do them exactly in the manner the program is expecting, or it'll be an error. So what you have to do is you have to compile. Once you finish writing a code, once you finish writing a sketch, as Arduino calls it, you have to compile it to make sure you haven't made any errors. And that's what this button here says, verify. So if I click on that, then down here at the bottom, you see that it runs and it comes up and it says, yeah, this program, everything worked fine, you're good. So then after you do that in the software, now you can download it. And you see that I've got the Arduino plugged in to the USB port on my computer, and it's COM port 6 right now, but that's immaterial. But you have to make sure that you're in the right COM port and all that. And then once you do that and you click on this button to upload to the Arduino, and right here is what has been happening to me consistently. And you see right here it says upload failed uploading, upload error, and it gives it exit status. And this has been my nemesis for months. Excuse me. And so what happens to me is that consistently happens. And so now this is running now because a while ago I was able to reboot the computer and got it to load into the Arduino. But I have not consistently been able to get that to happen. I just noticed my computer wasn't recording. Anyway. Okay, so in the software here, you see I've written the software for 35 turnouts, and I've identified the close function to be the even numbered ones. And these aren't consistent because basically what it amounts to is that you don't use all of the pins on the Arduino, but that's neither here nor there. But so I've got the even numbered pins as the close, and then the odd numbers are the trips or the throw. And so you see here odd numbers, and there's 35 of those. And then in this, those are just identifying that. And then the setup is, I say serial baud is begin at 9600, and basically what that's doing is that's telling the computer that you're going to communicate between the computer and the Arduino at 9600 as the baud rate. And then I identify the integers, and this is what's called an array. So I've divided integers so that I don't have to call out each pin individually as a separate line of code. We'll do it, and close I is an output, trip pins I are outputs, and then the initialization is we write everything low. So basically what that amounts to is that when you start the software, it will set every turnout to the closed position. And then the loop running the software is, it says if you get an input from CMRI, that input will come as expected as 0 through 34 for the 35 turnouts, and it will be an index as a serial read. And then that will determine what you do based on what that is. If it comes in as a 1, it will mean it wants to close, which means that then puts the close pin high for 500 milliseconds, and then it will go back to low. Now, what you want to make sure of is that it has to only be 500 milliseconds, because if it's any longer than that, you'll burn up the turnouts, which I learned that by experience. And then if the command comes in as 0 on any given one of those pins, which are identified by the I, then it will digital write the odd pin high for 500 milliseconds, and then go low after that. So that's the way the software is supposed to work. But for one reason or another, I keep getting this error message when I try to load that on the Arduino, and it has really been frustrating. And so I finally came to the realization that I think the problem is with the computer, because sometimes it'll load, but sometimes it won't. And so the problem is that I can't rely on this laptop to do what I need to do. And that's frustrating. Okay, so that's what the software is supposed to do. And here's the way it's supposed to work. You see, here's this is basically my track layout of the Newbie Mountain Railroad. You see, this is the mountain area up here, and all the turnouts are identified at this particular time by green circles. And the way it will work is that if I go down to this green circle and I click on it, you see it turns red, and that would send that signal from CMRI to the Arduino, telling the Arduino to trip that turnout. And if I click it again, it goes back to close. And you see that works on all of those. So the CMRI, the JMRI CMRI software is working okay. And sending the signals, but because I can't get the software to load reliably onto the Arduino from the computer, it's not working. It's frustrating, but that's the plan. I think I've showed you this before. So there you have it. It's just part of being newbie, I guess, that I don't know what I'm going to do about that. I've got another computer I can use. I really didn't want to use my good computer, but I don't know that I have another choice, because if I can't rely on the laptop computer that I'm using, it's not worth the effort, right? So, well, I guess that's it for today. You see Chief laying over there in the window. That's his favorite spot. He can lay there and watch the deer playing in the backyard, and he just loves it there. But anyway, that's neither here nor there. But so that's it for today. Just wanted to give you a little update of what's been going on and why I haven't been posting, because I've been just tearing my hair out. But anyway, so that's where we are. Appreciate you watching. Come back next time when we'll see what's going to happen.